find the determinant of a 2 by 2 matrix. So hopefully that stuck and you had plenty of practice with your 8 through 28 even, every other even, to be ready for today. Because today we're talking about minors and cofactors and finding the determinant of a 3 by 3 or a 4 by 4 matrix using expansion by minors. So first of all, if A is a square matrix, then the minor, and we have a capital M for minor because there's operations that have to be performed in order to make that happen. So the minor of row I, column J, is the determinant of the matrix obtained by deleting the ith row and the jth column of matrix A. And the cofactor of that minor is the of entry AJ or IJ, A sub IJ, is equal to -1 times the row plus column number. Sorry, -1 to the row plus column number times the minor M of I comma J. Okay, it looks difficult. Okay, we'll practice it and we'll make it make sense. Okay, so if we have a 3 by 3 matrix, okay, just look at the signs for the cofactors. Okay, this is the first row, first column, right? I and J are both 1. That means that 1 plus 1 is 2. We're taking -1 to the second power. Anything to an even power is always positive. Okay, so the cofactor for the sign of the cofactor for row 1, column 1 is positive. The sign for the cofactor of row 1, column 2 will be negative because 1 plus 3, 1 plus 2 is 3, and that is an odd power. -1 to an odd power is always odd. Okay? This is the first row, third column. So I and J are 1 and 3. You add them up, we get 4. -1 to the fourth power is even. Okay? So the sign of the second row, first column, is going to be odd because 2 plus 1 is 3, and anything to an odd power is negative. A negative to an odd power is negative. So far, so good? Okay. So to find the minor, we're going to remove the ith row and the jth column, and then we're going to find the cofactor by checking out the sign pattern. Okay, so here we go. We want to find the minors and the cofactors for that 3 by 3 matrix. There are a total of 9 minors. So when we want the minor of row 1, column 1, that means that we're eliminating row 1 and column 1 and finding the determinant of what's left. So when we eliminate row 1 and column 1, now we want the determinant, notice our vertical brackets, not our square brackets, of 2, 1, 3, 6. How do we evaluate the determinant of 2, 1, 3, 6? Yep, multiply the 3 times the 1 and change the sign. Multiply the 2 times 6 and keep the sign the same, right? And add the 2 up. So what is 12 minus 3? 9. The minor of row 1, column 1 of this matrix is 9. Okay. The minor of row 1, column 2 means we remove row 1 and column 2 and we rewrite our determinant. okay, or our matrix, and find the determinant of it. So downward diagonal, 18, upward diagonal, -1. Change the sign and add. 19. Okay. Now we want the minor of row 1, column 3. Eliminating row 1, column 3. We find the determinant of 3, 2, -1, 3. Downward diagonal, 9. Upward diagonal, -2. Change the sign. Add. To find the minor of row 2, column 1, multiply or remove row 2 and column 1, and then multiply your -2 times your 6 and your 3 times your 4. And change the sign of the 3 times 4. Add them. Make sense? We need to work all 9 of them out, or are you okay with these? Okay, we're good. Now let's find the cofactors of each. Okay, the cofactor has an impact on the sign of your determinant. Okay. First row, first column, -1 to the second is positive, right? So we don't have to multiply 9 by anything. It just stays 9. So the cofactor of row 1, column 1 is 9. The cofactor, though, of row 1, column 2 is going to be row 1, column 2. 1 plus 2 is 3. -1 to the third is negative, right? So we have to take change the sign of that 19. Okay. The cofactor of row 1, column 3, add the 2, we get 4. -1 to the fourth is positive, so we keep it the same. But the cofactor of row 1, column 4, sorry, row 2, column 1 is an odd power again. -1 to an odd power says change the sign, so it's a positive 24, and so forth. Okay, so you can either remember that power rule, or you can just simply in the corner somewhere write positive, negative, positive, negative, positive, negative, positive, negative, positive. And then remember to change the signs of anybody who has a negative. Okay, question? 2, 1 would be negative, but it was already negative. So a -1 times the -24 becomes positive, switches the sign. Okay. Other questions? All right, we're good with minors and cofactors, right? Okay, now here is how we find a determinant of a 3 by 3 using something called expansion by minors. In this particular method, you choose a convenient row or column, preferably one that has zeros in it. And you'll see why in just a moment. And then we expand the row or column by cofactors to find the determinant. Okay? In other words, if we have the determinant 3, -2, 4, 3, 2, 1, and -1, 3, 6, and we decide to expand that matrix by its top row, then that means we'll take 3 times the cofactor of row 1, column 1, plus -2 times the cofactor of 1, 2, plus 4 times the cofactor of row 1, column 3. Okay? So we did, I think this is the same matrix that we were just looking at. Okay. So when we found the first minor, okay, that was our 9, wasn't it? Okay. And we didn't need to change the sign because it goes positive, change the sign, keep the same sign. Or +1, -1, +1 times these guys. Okay. So we're taking 3 times that cofactor that we found in row 1, column 1, and a -2 times the cofactor, okay? And the cofactor of this one, we had to change the sign, right? And that was 19 when we found the minor. So -19 for the cofactor, plus 4 for that last row column. And we ended up with I think 11, okay? And it was positive for our cofactor for our cofactor for that particular value. Okay. Anybody want to see one of these worked again? Okay. All right. So 3 times 9 is 27, right? -2 times -19. 38, right? And then 4 times 11. We add them up and we get 109. Okay. So Caleb may have decided to do the first row and he would have gotten 109. Okay. And if Haley did the third column, she would get 109. And if Alex did the second column, he would get 109. But you'll have different cofactors, obviously, multiplied by other numbers. Does that make sense? Questions on this one? Okay. First row or one row or one column, and you find the whole determinant. Okay. Now I'll show you why it's nice to have zeros in just a moment. Okay, and we'll look at that right now. So let's find the determinant of matrix B. I'm sorry, Savannah, you had a question? It's going to be different depending on which row or column you happen to choose. So in this case, it was 3, -2, 4 because that was the row I chose. Okay, but if I had chosen to do row 3, for example, then it would be -1 times the cofactor of row 3, column 1, plus 3 times the cofactor of row 3, column 2, plus 6 times the cofactor of row 3, column 3. Okay, and I forgot to do the C. Question? With a 0. Yep, and you'll see why with the zeros in just a moment. Okay, any row or column, doesn't matter which. Okay, and it is beneficial to try to use zeros if possible. Okay, did you want to see this worked to make sure that you understand that it works? Okay, so let's do the next one. Okay, so the next one is matrix B. So we want to find the determinant of matrix B. So 3 by 3. The first row is 3, 4, -2. Second row is 3, 5, 0. And the third row is -1, 4, 1. So we're told to try to use a row or column with zeros if possible. So which do you want to use? Row 2 or column 3? Which one? Column 3? Okay, let's try column this time. Okay, our expansion by minors is going to be a -2 times the cofactor of row 1, column 3, plus 0 times the cofactor of row 2, column 3, plus 1 times the cofactor of row 3, column 3. Going this way. Okay, so that's why those numbers are out there. Now, does everyone see why it's beneficial to do a 0? 0 times anything, 0, right? So there's no need to write that new matrix or determinant here. Does that make sense? I'm not expecting to see it on your paper. Okay, So we know we're getting a 0 here. Okay. Now, what I typically do is I think of my sign pattern so that I'm careful to not mess up. Okay. It's positive, negative, positive, right? Negative, positive, negative, positive, negative, positive. Do we have to change any of the signs when we're finding our cofactors? No, because the sign change for 0, negative 0 is just 0, right? Negative 1 times 0 is 0. So we don't have to worry about our changing of our signs. So now we're just worried about our minors. Okay? So this is negative 2 times the minor for row 1, column 3. That means I'm eliminating row 1, column 3, and writing down what's left of my matrix. So we'll have a 3, 5, negative 1, 4, multiplying on the diagonal, multiplying the minor diagonal and changing the sign, and adding them up. We have that negative 2 out in front to multiply it by. Then we're adding 0, and then we're going to add 1 times the minor of 3, 3. So this time when we're finding row 3, column 3, we're eliminating this one and this one. And we get 3, 4, 3, 5, right? So on this downward diagonal, we get 15. Upward diagonal, we get 12. Change the sign and add. Okay. So negative 34 plus 3 gets us negative 31. Okay. Had you decided instead to expand by minors for the second row, you still would have gotten negative 31. Okay? But the zeros just mean that we have one less determinant to work with. One less 2 by 2. Make sense? Questions on this one? All right. Now, let me show you another way. Okay? For a 3 by 3. Our book doesn't teach it this way, but it was a way I was taught in matrix theory. And I'll explain why in just a moment. So you write your determinant like normal, but then you write an extra column. You repeat the first column and you have a 3, 3, 1, and you repeat most of the second column. You don't need the 5, so you repeat the top and the bottom. Thank you for catching me, and that should be negative there as well. I lost it because of the blue going through it. Okay, so we repeat the 2 rows, but we don't need that 5. Now, downward diagonals. 3 times 5 times 1, 4 times 0 times negative 1, negative 2 times 3 times 4. Upward diagonals, change the signs. Negative 1 times 5 times negative 2. Positive 10, change the sign. Negative 10. Okay. Upward diagonal, change the sign. 0. Upward diagonal and change the sign. Negative 12 when we change the sign. If we add 15 and negative 24 and negative 10 and negative 12, we get negative 31. Okay? So you choose whether you want to expand by minors or if you want to do the repeat of the second 2 columns, or first 2 columns. You will have to do minors when we get to a 4 by 4. Okay? And so that's why we teach the minors, because a 4 by 4 can't, the diagonal method doesn't work. Question? Nope. Because when we're going downward, 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 and upward, 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 this guy gets left out. So I just don't even bother to put it there, less confusion. Okay? So far, so good? All right, now 4 by 4. Okay. So here comes our 4 by 4. I'll let you write. I know you were watching. So we actually kind of use it when it's a 2 by 2, don't we? But also with a 3 by 3. Yep. And we just repeat the first 2 columns and then multiply. And remember to change the sign on the upward diagonals. Okay. All right, so here comes our 4 by 4. 4 by 4 has a top row of 6, 4, -1, and 0. Second row is 0, 0, -1, 0. Third row, 3, 1, 8, 7. And fourth row, -5, 4, 2, 3. I like it. So you're already strategically thinking, let's do row 2. Okay? And also let's keep in mind our sign pattern. Okay? First row, first column is going to be positive, right? Not changing the sign of that one. First row, second column, so this follows the pattern that we had with our first row for a 3 by 3. But now when you get to your second row, first column, we start with negative. So negative, positive, and so forth. So if you want to, quickly put your sign pattern on your paper when you're working these out, that will help you find your cofactor. Okay? And I often do that ahead of time so I don't have to worry about it later. Okay? So Ray suggested that we say, let's expand by row 2. Okay? He sees lots of zeros. Okay? Which means that we'll only have to find the minor of -1. Okay? Because 0 times the minor for the first row, or first column, second row, is going to be 0. 0 times the minor for the second row, second column is going to be 0. And 0 times the minor for the second row, fourth column is going to be 0. Okay? So we know we've got this -1. Okay? Let's think about it in terms of whether it's going to be positive or negative. Do we need to change the sign? Yes, because that's the second row, third column. 2 plus 3 is 5. -1 to the fifth is going to be a -1. Okay? Now we're going to take that column and row out to find our new 3 by 3 matrix. So if I eliminate this column with that row, I have 6, 4, 0. Now we've got a 3 by 3 to contend with. Do you see why I taught you the diagonal method on the 3 by 3? Okay, yes. I took this one. This is our cofactor piece. This is the -1 to this is the second row, third column, 2 plus 3, and then this is the minor. Okay? Absolutely. Okay? So I need to take, if I'm expanding by minors, I have to take this -1 from here and take it times the matrix that's left over when I eliminate its row and column. Okay? And then this is going to be the minor. Okay, I eliminated the row and column and got the matrix. And then this one comes from the fact that I need the cofactor. And it happens to be second row, third column. 2 and 3 is 5, and -1 to the fifth is going to be negative. Okay? Or if I locate this guy in my little pattern, I see that it's going to be negative. So change the sign. You have to change the sign of the -1 that was out in front. Okay. The 2 plus 3 is from the fact that it's the second row, third column. Okay. All right. So shall we do the diagonal method? Okay. Or we can expand by the first row or the second column. Doesn't matter. I think the diagonal method's easier. Okay. Everybody okay with doing diagonal method, or do you want to see it expanded by this first row or this third column? Okay, let's do diagonal method. So we rewrite and then we multiply downward diagonals. (28) times -5. Okay, and then 0, right? Now upward diagonals, we have to remember to change the signs. So we'll get a 0 this way and change the sign of 0, it's still 0. And then we're going to have 42 times 4, 128. 42 times 4, 168. So change the sign. And then 9 times 4, change the sign. So we've got 18 minus 140 minus 168 minus 36. -1. 326. And then it's being multiplied by a -1, so a +1, so my answer is -326. So we picked these numbers from here, 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 anything that was left over after we eliminated our row and our column. Right, I just repeated the first two columns, and I don't need the middle number. Okay, let's rewrite the first two columns. Do you want to see it with expansion by minors for one of those rows? Or are you okay?